Good morning and welcome to our presentation, Turnkey Energy Management Solutions. Not sure how we got that title, but we'll try to stick to that as best we can. We have a little bit of a focus today on condominiums. We have a bit of a history in condominiums, but anything we talk about really is applicable to all buildings. My name is Maro Trelli. I'm with Cricket Energy Holdings. And with me I have Imran Noorani. He's from Canadian Right Rate, which is a Cricket company. And Jason Schembri, who's from a sister company, Oz Electric. We were in the news yesterday, but I won't get into that.
No comment.
No. Just a little introduction to the companies. Oz Electric, some of you may know Oz. It's a fully integrated electrical contracting services firm. We specialize in new construction. We're working more and more in retrofits and maintenance in the commercial building marketplace. About 50% of our work is in the condominium market, and 50% is infrastructure in commercial buildings and hospitals. We originate in the GTA, but we now have offices in Calgary, Edmonton, St. John's, Newfoundland, and an affiliate company in New York City. And we just this month celebrated our 25th anniversary as an electrical contractor. Cricket Energy Holdings is a new company. We were established in 2013, and our focus is providing energy services to homes. We have a Cricket Home Comfort Group that deals with in the residential new construction market, businesses, homes, businesses, and builders. And we really look at how people use their electricity, equipment for their electricity, how it's delivered, produced, and purchased. So that's why we have Imran here from Canadian Right Rate. The Cricket companies, you may see our booth out there. We have Provident Suite Metering, so a lot of people would know Provident. They're probably as old as Oz now. At this point, they're from the 90s. And Provident Energy Management, Cricket Solar. We finance solar projects for a sister company called Oz Solar and do our own residential solar. And then Cricket Home Comfort. If you're buying a new house, you might come across Cricket Home Comfort in the new home marketplace. I just want a little brief introduction. When we talk about energy management, I've been in the energy management business now for about 30 years. I've worked with utilities, I've worked with government agencies, some consulting, some ESCO work, and a lot of retrofit and engineering design work over the years. I have trouble holding a job for more than 2 or 3 years, so I've moved quite a bit. And I'd like to say when we talk about energy management, we look at sort of 3 different areas of a building or project. We talk about capital projects, big retrofits. So these are tend to be driven by things like need for replacement, and really where the energy issue comes into play is if maybe you're going to replace early. But that's not what we're talking about today. Then we're talking about efficiency upgrades, and this is more or less what we're talking about today. And these are typically driven by immediate costs and technical opportunities, things that have changed in the marketplace. There's been some presentations today earlier about LEDs and stuff, and things that will drive a complete change, a quick change in the marketplace. And then energy procurement, and this is sort of comes and goes. This is something that's really affected by market conditions, and Imran will speak to that a little further on. Like all energy management projects, like all management projects, really have to understand what goes into your costs and what your consumption is. You know, and we're going to talk a little bit about this, but not too much. The cost history of your buildings is something you all understand. People see things going up in price. From a cost perspective, it's not necessarily their energy consumption going up. There's been issues with rates and electricity and gas costs and how they've been doing things. How you're billed, which gets more and more confusing every year, but what's actually going into your bill, your fixed costs, your variable costs, new costs that are being added all the time. How you consume and compare. What's that? Sorry. How do you consume it, where it goes in your systems, and how do you compare against other buildings, or are you actually, you know, there's always that issue. Everybody thinks their bills are high. People also also think that they're not the reason for the high buildings. So where is it actually coming from? From a condo perspective, I'm sorry, we dedicated a condo budget. Energy is a big issue in a condo, and it's about 40% of the condo's budget. And then maintenance of energy systems is probably another 20%. This varies from building to building. So it's about 60% of a condo's annual operating budget is energy related. It's also quite manageable compared to the other things. I mean, capital improvements you're kind of stuck with, reserve funds you're stuck with. There's always something you can do with energy. I'll talk a little bit about energy and what's gone on in the last few years. I'd like to bring Imran up to discuss this, as he's our energy expert and the market expert.
Okay, so I have the fun fun job of the doom and gloom job, I guess. So what I'm going to start with is how natural gas and electricity is structured in the market today. And I'm going to walk you through how to understand an electricity and natural gas bill, because before I joined the sector, I had no idea what my bill even meant. So we'll go through that as well. But the first thing I wanted to point out was everybody hears about how cheap petrol. I'm going to make a distinction between gas versus petrol. So natural gas is what we're using to heat our homes. Petroleum is what we're filling up at the gas pumps for our cars. So everybody, you go to the gas station right now and you can fill up for about 89 cents or 90 cents, whatever. Very cheap in comparison to what we've seen. And what's unique about the market today is that the drop in crude oil and petroleum has taken natural gas down with it. And we don't typically see that. The two are typically very separate commodities. They're traded very differently. But the main point really about natural gas is it is one of the most volatile commodities out there. And when you're with the utility, so more than likely you're with Enbridge or Union Gas, when you're with the utility, it's actually a very volatile ride. And most people don't realize that, because they think, okay, I'm with the utility, it's a direct pass-through, things are good. But it's actually, so the rate with the utility changes every quarter, so every 3 months, and you can see sort of how volatile things can get. Here's a good example of what happened around Hurricane Katrina. And here's a good example. So this huge jump over here shows you what happened after the polar vortex. So in Enbridge's case, it went from 11 cents to 22 cents from March to April 1st. And it gives you an idea of how bumpy the ride really is. Another interesting point about natural gas is that we're kind of at the bottom of the market. So we haven't seen prices like this since the late 1990s. You have these sort of anomalous dips in the market. This, for example, was when we discovered we had a lot of shale gas in North America. Prices went right down. They started to recover right away. But really, the point is that most people don't think about natural gas because the bills aren't high. So it's not something you pay attention to. The exact opposite is with electricity, where it's really, really high, so everybody's really worried about it. But the problem is that when you act when things are really high, you end up dealing with situations where you're locking in things at really high rates, and you're not thinking about the things that you should be thinking about when the market is actually low. The electricity story is very different in Ontario. So with natural gas, you saw it's a bumpy ride. With electricity in Ontario, because the way it's structured, things have just been on a complete increase. So since 2008 to November 2015, we've seen greater than 100% increase in electricity prices. And it's important to note that in natural gas, prices change every 3 months. In electricity, it actually changes every 6 months. So November and May of every year. And what we're generally finding is that your bill will increase about 6.2% on average every 6 months in just the supply cost. 6.2% is the average as of late. The long-term average is about 4.5%. But really, it's an increase, and it's just moving upwards. And this is where people think, okay, I really want to do something about this. How do I work around this? I'm going to explain to you later that there actually isn't many things that you can do in electricity, but it really makes a case for conservation as being one of the key things you can do. The long-term energy plan in Ontario from the Minister of Energy has actually pointed to some of the increases. So there was a lot of public pressure to start explaining why we're seeing these increases. And in their long-term energy plan in 2010 and 2011, they identified that these are some of the increases we're going to see. And this year is actually going to be one of the worst years, because one of the things that the ministry did was it introduced the Ontario Clean Energy Benefit in 2010, which gave every building a 10% discount. Unfortunately, that discount has now ended as of 2015. So this year, you'll actually see about a 16% increase in your electricity bills compared to last year, because that 10% discount has now disappeared as well. In terms of a typical condo building, Mario mentioned we're focusing primarily on the condo building as an example, but you can see that the increases that the government have been talking about, so about 33% over the next 3 years, let's just say, along with increased costs. If you look at the red line, that's sort of your total monthly bill. So it's sort of in the $38,000 range. By 2020, you should be right at about $52,000. From an annual budget, that's about $466,000, increasing to about $600,000. So about $150,000 more over the next 4 years is what you're going to need to budget for. And there aren't many forecasts done out there. This is a very conservative forecast as well, so it could be more than that. So again, like I mentioned, really what I'm trying to say is conservation is a really interesting topic, and you really should be paying attention to it right now in the market. In terms of understanding your bills, which I promised I would do, so here's a typical natural gas bill. Okay, I'm going to walk through line by line what these are. If anybody has any questions, feel free to interrupt me because they're going to be very valuable. The customer charge is the first thing that you'll pay on your bill. For a typical condo building, that'll be about $70. For you at home, it'll be about $20 a month. What it really is it's almost like the system access fee that you used to see on your cell phone bills. It's sort of a charge that you're going to pay regardless. It's the utilities charge to be able to come and read your meters, to respond to emergencies. It's really regulated that they can charge this, and they're going to continue to do it no matter what. So you really can't fight them on that. I should mention as well, so this is an Enbridge bill. Enbridge is the final biller, or in the case of electricity, let's say it's Toronto Hydro, they'll be your final biller. But they're actually representing many people in the value chain. So they're representing people like the generators who actually create the natural gas, the transporters who send the natural gas across the province, the distributor, which is Enbridge, who's actually sending it through small pipelines under the city that we live in, and they might even collect for the regulatory environment, like the Ontario Energy Board or other people who look at the sector and manage the sector. So they're collecting on everybody else's behalf. So it's important to understand that they're actually not keeping this entire bill. They're remitting payments to other players as well. So the customer charge is something that they keep. Then you've got the delivery charge to you, which is really Enbridge's charge. So I'll show you a diagram in a second to explain the difference between transport and delivery, because you'll see that on your bill as well over here, transportation to Enbridge. But really what it is when you're, let's say, at home, and one of your side streets has been dug up for 2 months and it's really frustrating and you're wondering, and there's an Enbridge sign, what the hell is going on here? Well, it's likely that your community is growing in size, so Enbridge has had to come in, dig up under the ground, add new pipeline arteries, as I like to call them, so that gas can be delivered to each home. And you'll see a site restoration clearance as well charge on some of your bills. Really what that is related to is, depending on the area that you're in, Enbridge has to recover the land to its original status after they dug up the land. So that charge might be on there as well. Then you have the transportation charge to Enbridge. What it basically means is Enbridge is going to get its gas at a border. It's actually at the Alberta-Saskatchewan border. But basically, Enbridge picks up its gas from there. Most of the gas actually typically comes from the western basin of Canada. So think the mountain ranges around BC, right? So the gas that travels through big, thick pipelines, huge ones that they expropriate land for, and there's a lot of controversy around, that's transportation. 50% of your bill, roughly, is made up of charges that are related to getting the gas to you. The gas supply charge is the cost of actual gas. So that's the actual gas that you're using, and it's about 50% of the bill. And this is where you as a condo board actually has control. So in Ontario, you can choose to buy your gas from somebody else, or if you don't make a decision, it's going to come from Enbridge. The market is very interesting in Toronto because you have this default supply with Enbridge, whereas in the rest of the world, like countries like England, New Zealand, you actually have to make a choice. And in Ontario, they've sort of said that the default supply is Enbridge, so just go with that. And people have this perception that Enbridge is the only choice. You actually do have choices, and like I mentioned before, with Enbridge, it's a variable rate. Finally, you'll see on there a cost adjustment. I mentioned earlier that Enbridge sets its rates every 3 months. What they do actually is they set their rate for 3 months, and it's a forecast of the next 3 months, because they've got to guess where things are going to land. When they get that forecast wrong, they've actually got to charge you for whether it was greater or less than. And that's what you see in the cost adjustment. Really, on this bill, for example, it's a credit. Right now, we're seeing with Enbridge and Union Gas, it's a debit, so it's a positive charge. The reason for that is because the polar vortex was so difficult to manage. There was about a $4 billion loss for the entire industry. So they're recovering that cost over 27 months. So for the next little while, it's going to be a positive charge. But that's going to end, thankfully, actually, at the end of, so September 30th this year. We'll finally see the market going back to normal. But that's an example of what a cost adjustment is. And a cost adjustment really can be made up of 3 charges. Enbridge is now actually breaking it down. It's made up of a missed forecast for transportation, a missed forecast for delivery, and a missed forecast for gas supply charge. So it's actually made up of 3 things. This is the difference between the pipelines that you see sort of in your neighborhood, Enbridge putting it sort of under the ground, and the big transportation pipelines that send large volumes of gas across the city. Sorry, across the country, pardon me. This is an electricity bill. It's actually structured very similar to a natural gas bill. And what you'll see here is you've got the same kind of idea. So the first line item there is electricity supply. This is a bill with Toronto Hydro, by the way. So here you see that the customer is being charged X amount of kilowatt hours, which is the unit of electricity, times 0.088, which means 8.8 cents. So most condos are actually on what's called the regulated tiered price plan. And if you have questions about that, I mean, it's fairly complicated to just talk about in the presentation. Feel free to come up to me after, and I'll explain the rate that you get charged at from Toronto Hydro for a condo. But in general, this, on the electricity side, is about, let's say, 55% of your bill, whereas in natural gas is about 50%. But you do have a choice here as well. With delivery, it's very similar. The way I like to think about it, so you've got distribution charges, transmission charges, the customer charge that we saw earlier, which was $70 on natural gas, very similar with Toronto Hydro as well. For a homeowner, it would be about $21 or $22. I think they just increased it. And then you've got distribution and transmission, which is very similar to natural gas. We've got delivery and transportation. And the way I like to think about it is transmission is the big Eiffel Tower like structures that you see when you go to the cottage or when you're going into rural Ontario. It's high voltage power lines sending electricity across the sort of provinces. And then you've got distribution charges, which is more of the poles that you see. If you're driving downtown Toronto, you'll see the streetcar passing through, and there's all these wires on the top and sparks. Those are actually distribution lines coming across as well. Typically, in newer developments, it'll be underground. And then you've got, Then you've got regulatory charges and wholesale market charges. These are really just the charges to actually run and administer the markets. Electricity has many different players in it, like the independent electricity system operator who balances demand and supply every 5 minutes. It kind of looks like a Star Trek ship if you go to their office. It's actually quite interesting. But they have a very tough job in Ontario. And then you've got the Ontario Energy Board who's regulating the sector as well. So there's a charge. It's not very large, actually, on there. Then we've got a final charge, which is quite controversial. It's in the newspaper a lot these days, the debt retirement charge. That was the cost of us purchasing Hydro 1. And it was called Ontario Hydro, and then we purchased it and split it up into many different companies, Hydro 1 being one of them, and we're still paying that debt off. It was about $20 billion a little while ago, and now it seems to be about $16 billion, so there wasn't much of a draw there, but it's in the newspaper a lot because of the sale of Hydro 1. But in any event, really, when you're looking at the electricity bill, very similar to a natural gas bill, you have about 55% in your supply. The rest is sort of out of control, but it's made up of your customer charges, your delivery charges, and your regulatory charges. Okay, I'm going to stop now, and I'll pass it on to Mario again.
Sorry about the lesson on bills, but I think what we wanted to take away is when we're talking about opportunities or turnkey opportunities or simple opportunities, about 50% of your natural gas or heating is manageable in the sense of procurement. Similarly for electricity, though maybe not quite the same opportunity. When we talk about turnkey measures, where you're using your electricity or your energy is key. Everybody understands where your natural gas is being used, your electricity is being used. In condominiums, there's a miscellaneous component or a suite, a little harder to get to. But you have a lot of the system fans and the lighting and a lot of 24-hour load that is going to be significant in these buildings. One thing also, and this is again the condominium example, There's always that image, an idea in a condominium that the suites are small, they don't use a lot of electricity, but if you or a lot of gas. But if you look at condominiums in general, on a per suite basis, all the energy consumed, it's a lot more like a house in numbers and sometimes quite large. And one of the reasons that is in today's modern condominium, the newer ones, over 50%, commonly almost 60, 65% of the electricity and gas used in that building is used in the common areas. There are things that are directly affected. You know, it's always interesting, but the biggest component of the common area management is going to be your energy. And a lot of that is because it's 24/7, similar to other commercial buildings, hallways, stairwells, underground parking, recreation areas, pool areas. It runs nonstop. So while the unit owner might think, I got a little house and I'm turning off my lights and I don't have, you know, I'm not using my fridge and I'm not home, the rest of the building is humming all the time. So we want to talk about immediate opportunities and what we call turnkey opportunities. And really when we're talking about those, we're talking about projects that are so good, so common, and maybe because of, these folks have bid on electricity for various reasons. One is the prices skyrocketing. So we talked about commodity prices, the technologies that are hitting the marketplace right now, and there's been some discussion. Some of these technologies tend to drop in price, get cheaper, get better, and some technologies are getting cheaper and better faster, and Jason will talk about that, than we actually expected even a few years ago. It's a turnkey project because these projects are so good that financing is typically available. Companies like, again, Cricket would finance a project that in one of these projects if Jason brought it forward, just because it's such a good turnaround. And then the government utility incentives, I don't know if some of you are for the Toronto Hydro things, the incentives are actually quite significant. We've added to that commodity because there is actually a turnkey or an immediate opportunity in the commodity market, and Imran will talk about that a little later as well. We just want to mention the incentives. They've already mentioned they're trying to spend $1.8 billion in the next 5 years. They're going to spend it. They're going to try to spend it. You might as well get your piece of it. You don't, and it's an interesting situation, and Jason will talk about it. You probably don't need the incentive to make it work, but it's there. And in a turnkey project, your project manager should be making sure that you got the maximum incentive, you got the maximum turnaround. It should be packaged as a very nice, sweet deal. At this point, I'd like to turn it over to Jason, who spends most of his time in the basement of buildings looking for these opportunities, and he has some examples.
First of all, thank you for your time and actually making out here to take part in this presentation. We'll look at a couple of different opportunities that we find every day when we're going through different condos across the GTA. Okay, opportunity one obviously is lighting. It's a low-hanging fruit, you might say. There's obviously, in a condo, you have a lot of 24-hour-a-day lighting, so the opportunity to save, considering it's on 87, 60 hours a year, obviously the opportunity to save is substantial, hence the term low-hanging fruit, because it'll be the quickest ROI for any project you do within the building. As you can see, we'll go over a couple of different things. We'll look at LED lighting as an option and different occupancy controls, whether it be dimming or on-off cycling of lights, but a lot of different ways to approach energy savings via lighting. And most of these jobs we're finding out right now, most of these projects, they're cash flow positive right off the hop. So it's almost a no-brainer to look at lighting as a viable option to save energy when looking at different ways to cut down on consumption within the building. A lot of the projects I've done in the past were corridor lighting, and you'd find a lot of these PL fluorescent lamps with external ballast, and they're really maintenance heavy. The lamps are rated for 10,000 hours on average, and almost 9,000 hours a year if they're on 24/7. So you might get 13 months out of a fluorescent lamp like that. So if you're spending, let's say, $5 a lamp, and there's 2 lamps per sconce, you can fathom how much maintenance cost there is there. A lot of people concentrate on energy savings, but really there's a lot of maintenance savings to be had when implementing lighting retrofits. Do a lot of also linear retrofits. We're doing a lot more LED conversions of existing fluorescents, and that seems to be commonplace for a lot of different ESCOs and lighting companies. A lot of conversion of existing fluorescent linear fixtures, so what you find in a garage, 4-foot lamps, to direct fit LED tubes and also LED tubes with external drivers. That seems to be commonplace right now. Okay, so another option obviously is manufacturers. When we talk about LEDs, everybody was apprehensive as recently as 2 years ago with LEDs because they didn't know where it was going. But when you have all these large companies investing literally billions in advancing their technology, you end up, as Mario stated before, a cheaper LED alternative with a higher efficacy, higher lumens per watt than what we had as recently as a year ago. So the technology is advancing day by day. So more than ever, LED has become a viable option. And that we hint to this right here. So the diodes, LED stands for light emitting diode, and the nice thing with LEDs as opposed to, let's say, halogens in the past, the halogens, looking at 100%, 95% of LED is light, maybe 5% is heat, which is dissipated through heat sinks, which you'll see on the top picture there, right there. So heat sinks that would emit the heat. So you got 95% lumens output from a 5-watt lamp, and hence a 5-watt lamp, now we can get 500 lumens of light out of. A halogen, on the other hand, gives off a ton of heat, and obviously gives off a lot of light as well, but it's almost like a 50-50 shifter. It's a lot of heat dissipation, a lot of heat generated by the lamp, so a lot of the energy it consumes, the comparable halogen to that light there would be about 50 watts, and it would be equal lumens output, so 50 watts down to 6 or 7 watts, and the same amount of lumens output, but this fixture right here, this lamp right here, that 6 watts is almost all light, whereas the halogen, it'll be almost half and half heat to light. So that's kind of the downfall of halogens. Plus, they have a very, very short lifespan. So once again, maintenance costs are through the roof for that. Now, what we find a lot as well for warehouse applications, garage, we're retrofitting a lot more the high HID fixtures like metal halides, high pressure sodiums to LED, and you can either, there's two options, we can retrofit, or you can retrofit the existing fixture, or you can implement a new fixture overall. So nonetheless, whatever route you take, you're usually going from, hypothetically speaking for a warehouse, a 400 watt fixture, in theory you can replace it with 150 watt LEDs. So quite the reduction in consumption, but the lumens output will stay consistent. And with the LEDs, the light output won't degrade over time like a HID would. So it stays true to the amount of lumens it gives off of over time. Eventually, obviously, it'll dim, but usually, on average, 5 years until that fixture will hit 70% of its original lumens output. So it takes quite a bit of time to degrade. Here's a job we did over in Windsor, and this will give you an idea about efficacy. I mentioned efficacy, that's the lumens per watt generated by the fixture. So what we have, so what we have here is 70 watt high pressure sodium and a 70 watt metal halide. It was a mishmash of fixtures in this parking garage in Windsor. So with the ballast, you're looking at around 92 watts. What we did is we put in linear LED fixtures at 36 watts each. So to go from 92 watts to 36 watts, quite a substantial reduction in consumption, but you could take a look at here, the lumens output's phenomenal. So LEDs advance to the point where you're cutting down the consumption in half and increasing lumens output. So let that be a telltale sign as to what to expect when you're converting HID to LED. So the savings are substantial, and obviously you can see the end result is higher lumens output. So that's thanks to the advancing of the technology, as I mentioned. So it's amazing the efficacy they're getting. They're getting 120, 150 watts out of efficacy, 150 lumens per watt now. A couple of years ago, 80 lumens per watt was pretty aggressive. So the technology is advancing day by day. Here's a condo in the GTA where LED wall sconce was PL, so that stick-style fluorescent PL with the external ballast was retrofitted to LEDs. And the numbers, these are the numbers, they really don't lie. $32,000 for the actual project, that's pre-HST. Estimated energy savings of $24,000. Once again, that's thanks to the 24/7 lighting. And a 1.3-year payback, not including incentives. So even without incentives, that's a pretty aggressive number. Now, once you implement the $10,000, you end up with, like I said, a no-brainer payback of 11 months, which is phenomenal. And here's another, an older building, and this was actually VFD and LED job. We'll touch base on VFDs in a couple of slides, but once again, if you look at these numbers, $40,000 for the overall cost. what was installed were 60-watt LEDs in the parking garage to replace a 150-watt high-pressure sodium, so quite the substantial drop in consumption. So $40,000 for the total project cost, estimated savings of $16,000. We should probably round off numbers. I don't know if we can stand true to the $315 if that was actually met, but for argument's sake, we'll say $16,000 in savings, 2.5-year payback. You implement the incentive. So for the VFDs, we would add a natural gas incentive of 10 cents a cubic meter and electricity incentive on top of the lighting. You ended up with a phenomenal 24-month payback, 2 years, which is, I'll take that any day. Okay, opportunity number 2. So this is what we're going to see, I think, more and more going forward, especially in condominiums, dimming controls and occupancy sensors. What we find, what I've been doing over the last decade, not to age myself here, but for the last decade, we've been implementing occupancy sensors in garages and lockers and what have you. And there's 3 options for occupancy sensors. There's PIR, passive infrared. There's ultrasonic, which is via echoes, much like a bat or a dolphin. And then there's dual technology, which implements both technologies in one sensor. Passive infrared, it just, the heat anybody would give off, it would detect it and relay the fixture to come on or to dim, or to go from dim to full output. Ultrasonic, as I mentioned, it'll go off of vibration, so it actually can go around pillars. It doesn't need an unobstructed view. Passive infrared needs an unobstructed view to be able to detect motion. And the PIR, once again, or the dual technology implements both technologies in one, is probably the most effective route to take if you want to cover all your options, especially for lockers where you want to make sure everybody is seen and the lights don't go off while somebody's rummaging through their lockers. That's the last thing you'd want. So now when we're talking about different retrofits, like I said, we mentioned lighting was obviously a great option, but what we're doing more and more, and what you'll find done more and more in apartment buildings and just any building in general where there might be carbon monoxide present via, let's say, combustion engines and vehicles or what have you, is carbon monoxide detecting systems. Now this system, as per building code, you can't turn off the exhaust fans in a parking garage unless it's controlled via a carbon monoxide detection system. So this system detects a certain parts per million of carbon monoxide to oxygen and kicks on the fans accordingly. When the zone is declared to be safe by the sensors, the fans will go off. So generally speaking, what I've seen in the past, you go from 24-hour runtime for the exhaust fans, and assuming an exhaust fan is 2 or 3 horsepower, there could be as much as 6 to 12 exhaust fans in a garage. You go from 24-hour runtime down to roughly 45 minutes a day. So substantial savings there. And when you're looking at incentive, the incentive for carbon monoxide detection is twice that of lighting. Since it's a controls incentive, you end up with 10 cents a kilowatt hour or $800 a kilowatt, the greater of the two. So lighting will get 5 cents a kilowatt hour or $400 a kilowatt. So let's see here. Here's what that sensor would look like in your garage. They usually run down the pillars. Everything's running conduit, so it looks nice and clean. When we're doing the incentives, what we've done in the past is we've generally calculated incentive based on 75% savings. So that'll give you an idea. At the very least, you're going to save 75% of the existing consumption by implementing carbon monoxide detection. One of the interesting side notes to carbon monoxide detection is the adjustment to the ambient temperature. Without bringing in that 100% outdoor air all the time, in winter you're going to have a milder temperature in the garage, and conversely in summer you're going to have a milder, less humid temperature in the garage. So especially if you happen to have fluorescent lighting, which doesn't really like the cold, they tend to dim in cold. If you have a CO system, it will help assist the fluorescent lighting in maintaining its lumens output instead of dimming due to the cold temperatures. So there's actually several different factors to maybe look at implementing carbon monoxide detection, not just the actual savings, but a more comfortable temperature. One thing to keep in mind, though, when you're implementing carbon monoxide detection is there is ongoing maintenance costs. These sensors need to be calibrated semi-annually to annually, so that's something to think about. But generally speaking, the cost to calibrate is anywhere between $30 to $50 a sensor. So it's not astronomical, but the savings are. So, okay, here's a job we did. I believe this is in Scarborough. Was just carbon monoxide detection, that was it. It was $14,000. We ended up with an energy savings. There's quite a few exhaust fans and larger ones. Energy savings of $6,680 annually, 2.1 year payback. A healthy incentive of $4,400. You ended up with a 18-month payback, or 1.5 years. So once again, all these retrofits, I started doing retrofits in 2005, and back then, a good payback was 3 to 5 years. Now, it seems like most of the proposals I'm putting out there, the paybacks don't involve years, they involve months. So it's definitely a promising sign. So variable frequency drives. We mentioned this before, that we would talk about this. This used to be a rare retrofit, you might say. Not too many people were doing it. Now it seems to be commonplace. We're finding VFDs on all sorts of applications. Makeup air units, so the corridor fans in your condo. Booster pumps, which brings the domestic water to the roof. Heat cool pumps as well. We're finding that quite a bit. So VFDs are starting to become commonplace in condos. And now how that works, it just slows down the motor to meet demand, as opposed to running, let's say, 1,800 RPMs or 36 RPMs 24/7. I assume that wasn't important. But so a lot of savings to be had by slowing down that fan. Now, if we look at the incentive for VFDs, there's two options. There's the dollars per horsepower, and then there's actually the engineered incentive, where you can calculate the pre and post consumption and get a dollars per kilowatt or 10 cents a kilowatt hour. Once again, great payback, great savings. When we're actually doing, when you find VFDs being done, 9 times out of 10, the motor's being changed as well, because once you slow down an existing motor, it tends to overheat, so it's always good to match a new motor with a VFD, something that's VFD rated that can handle not overheating at slower speeds. So that's something to be cognizant of as well. Now, VFDs, so what we're doing also, and what seems to be commonplace in a lot of condos as well, is the booster pump VFDs. We're seeing that more than ever, where your existing building might have booster pumps that bring that city water up to the roof, and you need to obviously pump that water up. It takes a lot of effort to get that water, 13 to 20 stories up in the air. So you got pumps that are cycling at 3,600 RPM, so 3,600 revolutions per minute, and you have a valve that closes and opens based on demand. So even though that pump is running 100%, it's almost like pushing your gas pedal while you're driving and adjusting the speed via the brake. So it's the same kind of premise. So it doesn't really make sense energy-wise. So a VFD, instead of running that motor at 100%, it'll run the motor based on demand. So the motor will run, instead of, let's say, 3,600 RPMs, maybe 800 RPMs, because that's all that's required at the time. And the savings there, obviously, are going to be significant. For a makeup air unit, what you see on that slide here, the savings for something like that, if we were to slow down a makeup air unit via variable frequency drive, you'd end up saving quite a bit of money on electricity, because once again, the motor's slowed down, it's not running at full capacity, plus you'll save quite a bit in natural gas as well. And once again, it's good for incentive via natural gas through Enbridge and electricity through your local distribution company. Here's a job we did in the GTA. This is a VFD and CO system plus lighting retrofits. So this is going to be a quick payback, because we've implemented several different retrofits in one specific application. So we end up with a cost of $30,300. I think those numbers pretty much speak for themselves. Almost, it's pretty much paid for itself in a year, and then the incentive is just gravy. You end up with a payback of 7 months. So. Once again, when we're going over these numbers, these are strictly energy savings, nothing to do with maintenance. The maintenance, if you factor that in, would be pretty impressive. Okay, I'll hand this off to Imran.
Okay, I'm going to talk about procurement, which Mario mentioned earlier as well. So you'll hear a lot about fixed rate contracts. You'll think a lot about electricity, seeing how quickly it was increasing. Really, what I'm going to tell you is stay with your utility for electricity and think about a natural gas contract. And I'll tell you why. I mentioned it earlier. Electricity is really high right now, and everybody's thinking about it. Natural gas is really low, so no one's thinking about it. Think the opposite. Natural gas is low right now. That's why you want to be thinking about fixed rate agreements in that sector. When I started, when I was actually working at the Ontario Energy Board, setting pricing in Ontario, the one thing that became very evident to me is there's a lot of people going out there and saying, I'll give you a fixed rate electricity contract. What they're not showing you is what the actual breakdown of that contract actually is. So we looked at the bill earlier. What I want to do now is just break down the supply portion a little bit. Sorry, here. So this is your supply portion, 44 and 24. Things, I mentioned 55% as being what the supply is made up of. In a home, it might be a little bit different. But your supply is made up of two charges. It's made up of what's called the hourly Ontario energy price and the global adjustment. So the blue is the global adjustment. The hourly Ontario energy price is the gray part. The hourly Ontario energy price is the actual cost of electricity in Ontario. That only makes up about 24% of your bill. The remaining blue portion, the 44%, is actually made up of the government-regulated charges for green energy in Ontario to move us from a coal-free economy to what we are today. So they've entered into private agreements with renewable energy generators, and the cost, so for example, if electricity supply costs about 11 cents in Ontario, if you have a feed-in tariff program in the original contract for solar, it was 80 cents. 80 to 11, there's a big difference there. That money comes out of this fund over here, the global adjustment. The conservation programs that we were identifying earlier, the $1.8 billion, where does that come from? It doesn't come from taxpayer money, it actually comes from ratepayer money. So it comes from here. So really, my point is on electricity, stay with your utility. Trust me on that. I used to set the rates, and it is the best structure out there for a condominium. And really think about incentives, because whether you like it or not, you're paying for it, whether you use it or not. And you're paying for it through the global adjustment. The natural gas market, you've seen this slide earlier, is very different. Really, I just wanted to make a point that prices are quite low right now, so it's the time to think about it. And this shows the drop in crude oil taking natural gas down with it, which we don't normally see. So that's an anomaly. Usually people think that the two things are quite correlated. It's only correlated when prices get really high or really low, because people start switching fuels. And it's really a very unique circumstance. For anybody who deals with commodities like I do, what we're currently seeing in the market is things that you only see once every 30 years in your career. So it really is an interesting time, and if you want to talk more about it, I'm happy to talk about it. That was really my message, is on the natural gas side, there's a good opportunity. On electric, think about conservation. I'm going to end with, I'm going to pass it to Mario here.
We're happy to take some questions. I just wanted to thank everybody. I don't want to hold anybody up because I know lunch is going to be served, and I think we're on schedule here. Let's try to finish a little bit before so you get in line for the food. You can also visit us at the booth. I just want to leave a few things. We talked about turnkey measures. We talked about electricity going up in price and continuing to go up in price. So those paybacks were simple paybacks. Obviously, next year's going to improve that payback as the prices continue to rise. So there's really no reason to avoid those. We looked at 3 or 4 things. They're common in all buildings. Any 24/7 lighting load, even 16, 20-hour lighting load like you might have in an office, it's an opportunity that you're not going to see for a while. I mean, it's going to continue to get expensive, but the incentives are there now that just drive it that much better. Controls, we talked about matching your load to your controls, those kinds of measures, whether the VFDs, whether the CO sensors. I'm trying to think of other things in the building, but those are very common. So they're so common now that, like I said, they're turnkey in a sense of like companies like ours, we're an electrical contractor, a little different. We're not like somebody like the lighting retrofit guy. We look at your building, we'll package the deal, you do the audit. Everybody's kind of doing the same thing. It'll be financed. It's like a bought sell, almost a specific product, and then we'll put through it together. And I wanted to add the procurement one, just because it gets ignored, gas pricing. People are always nervous about gas pricing, but it's low. I don't know how much lower it can get. I mean, we're dropping down to record lows, but it's still volatile. And so a procurement contract gives you a chance maybe to save energy against a future, a hedge, but it also gives you a chance to reduce your volatility. We have cards information here, but if anyone has any questions now, be happy to take them.